Hello everyone, welcome to this tutorial video. In this tutorial video, we will discuss one problem statement named maximum points. Okay, so after reading this whole problem, we can conclude that this problem, this problem have an array which denotes the maximum points scored in each game by Hawks player. Okay, and we have one variable k. What this variable is denoting is um, we want to find the highest point scored in every possible sequence of k consecutive games. Okay, understand? So the input format is be like for first line contains number of test cases t, and for the further lines, the first line contains an integer n, the total number of games played by the Hawks player and k consecutive games. Okay. And the second line contains an array points of size n, representing points scored by Hawks player in each game. And the constraints of this problem for this problem is n lies between 1 to 10 raised to power 6, k lies between 1 to n, and the element of array lies between 0 to 10 raised to power 6. Okay, so let's understand first test case. So here is the test case 1, where we have input n equals to 8 and k is equals to 3. So what n equals to 8 is denoting the size of the array and k is equals to 3 denoting the size of the sub array we want to check for. Okay. And what is the array given here is 1, 3, 1, 2, 5, 3, 4, 5, 6. Okay. These are the elements of the array. Now what we want to do is we want to we want to find maximum of all the sub arrays of size k of consecutive all the possible sequences of sub arrays of size k. Okay. So here from when we start from like look this example, array equals to 1 3 1 2 5 3 4 6. Okay, we have this array. Now we make one sub array like 131 of size k. Okay, of size k. Look this 131 of size k, 1 2 3, k is equals to 3. So we have this array. Now we have to find the maximum of this sub array. The maximum of this sub array is 3. Okay, now we move this subarray. I mean, we want to find all the possible sequences. So we move this. So we just move like this, and now we find the maximum of this new subarray. So the maximum of this new subarray is 312. The maximum is again maximum is 3. Okay, like if we look here. Okay, so this is the first subarray. This is the second subarray. Like this is the first subarray. And when we remove first element and add the fourth element, we this like this. This is the second subarray, and so on like this. This is the third. This fourth. This one is fifth. This one is the sixth. Okay, and we want to find maximum of all these subarrays. Like here 131, the maximum is 3. Here 312, the maximum is 3. Here 125, the maximum is 5. Okay, so what we are doing is we are just 1 minute. So here what we are doing is we are just removing the first element and adding the fourth element, the very next element of this window of the subarray basically. Like 3 1 is here also, but we just add the next element of the subarray. Okay, we are doing this until we got last element in our subarray. Understand what is the problem? Now we can do this problem using sliding window approach. You know what is sliding window? It's a very famous approach for this type of questions. Like if you look here, this is our sliding window. This is our window. This is our window. what we are doing is sliding this. We are just sliding this window like this only. Okay, until we got the last element inside our window. So the time complexity of this approach is um, we are iterating for n times because we want to access all the element of the array. Understand? So we are iterating all the elements, and after for each k sub arrays, we are finding the maximum. So for finding the maximum, we need to iterate for k time also. So the total time complexity comes out to be big O of n multiplied by k. It means n multiply k means for n elements. We are iterating for n elements because we want to access all the element. Understand? And for each sub array of size k, we are finding maximum, so we need to iterate all those element also. Understand? Therefore, the time complexity comes out to be big O of n cross k, which is very costly in this case. Understand? So, is there any better approach? Yeah, there is one better approach in which we can do one thing. What we are doing here is we are first we are first making subarray and then finding maximum. Then we are finding maximum of that subarray. Understand? Like we have this subarray 131, and then we are finding the maximum element in this array by iterating all the three elements. So the one thing we can do is we can store element in decreasing order. Means we need to store elements in decreasing order. Means first element is the biggest element, then smaller. It means decreasing order. Understand? So we can easily find the maximum because for each k consecutive times, the maximum element is we are storing the maximum element at zeroth uh, um, zeroth index of our window. Like we store all the indexes in the decreasing order. Okay, so we made this index array and we store indexes in the decreasing order. We start with this one. Okay, so we stored zero, index of this element zero. Now we move to the next element, this element. Now we check this element is greater than the previous element or not. So 3 is greater than 1. Yes, obviously 3 is greater than 1. So we want to store in decreasing order. Then the previous element should be greater than the next element. So we remove this. We remove this first index and store the index of this second element. It means 1, which is 1. Okay. Now we iterate to the third element, which is 1. So 1 is less than 3, its previous element. So yeah, we can store it uh, in this array index. Okay. So we store the index of this element, which is equals to 2. So after all the k steps, okay. After k steps, I mean, mm, like if we need to check for three consecutive times, we need to check for three consecutive games. It means we want to check in in a sub array of size k, or k is in this case k is equals to 3. So we need to check at least for three times in starting to find the maximum element. Understand? So we check for three times. Now we print uh, here. So we store very first element after k consecutive iterations. So we store 3 in the result because at the zeroth index we have 3, which denotes the maximum element. Now What we are what we need to do is we just need to shift this window because we want to check all the possible subsequences of size k. Understanding what I'm trying to say is, so we move this window like this. Oh, wait a minute. We move this window like this. What we are doing is we are just eliminating the first element and adding the next element. Now we again check like what is the next element? 2. So we check is 2 is greater than the previous element, means 2 is greater than 1 or not? Yeah, 2 is greater than 1. Then what we do is we just we just remove this element, this index, and store the index of 2, which is equals to 3. Okay. After doing this, the maximum element is same, which is 3. So we return 3 again. Understand? We return 3 again. Now, again we move this window, okay, like this, like this. Now we eliminate 3 and add 5 to this window. Now we will check is 5 is greater than the previous element, means 5 is greater than 2. Yeah, obviously 5 is greater than 2. So it should come before 2 according to us. So we remove this 3 and again we check 5 is greater than 3 because here 1 indicates the index of the element 3. Understand what I'm trying to say is 5 is greater than 3? Yeah, 5 is greater than 3. So we remove this index also and then we store the index of 5, which is equals to 4. After this step, we only have 4 in the array, 4 in the index array. Then uh, we add this value to the result because the very first element of this index contains the index of the maximum index of the maximum of the sub array. Understanding? Don't get confused. Like we again then move this window. Now the next element is 3. Yes, 3. So we again check is 3 is greater than 5. Yeah, 3 is not greater than 5. So we can store it in like this. We can store the index of 3 like this. Again, the first we print the element at the index 4, which is equals to 5. Understanding now? We are again and again we are just storing the the value at the index 4. Why? Because we are storing um, we are storing indexes in the decreasing order. So the very first index at zeroth index contains the index of the maximum value. Understanding? Understood? Now we are doing the same for until we get the last element in the subarray. So like this. Then after 5, we have 3, 4, 6. So we have 5, 3, 4. The maximum of 5, 3, 4 is again 5. And then in last subarray of 3, 4, 6, the maximum element is 6. So we write 6. So this is our result. So here is the code. Okay. So we first initialize the function main and gives the argument array n and k. Then we initialize one list to store the maximum of subarrays and then deck to store indexes of useful elements, which will work as as sliding window. Okay. Then we use for loop for I in range n because we want to iterate all the n elements. Then this first condition, this first if statement, this statement helps to remove elements from the front that are out of the current window. Okay, what we are doing is we are just removing the first element. When we shift our window, we are removing the first element and add the next element. This is the same. Okay, deck dot pop left. It means this is removing the left element in our deck. Okay, understanding? This if deck, it means deck should not be empty and the element at deck 0 should less than I minus k plus 1. It means I minus k plus 1 means this is the length of the sub array. So this is the length of subarray minus 1 means the 2 because we have the subarray of size k. So if we remove the first element of the subarray, this will become k minus 1. So this is the same thing. Okay. So and we use this while loop to remove all elements from the back that are smaller than the current element. What we are doing in uh, we see in previous explanation that we are removing the smaller elements and we are removing the smaller elements from deck. So this is doing the same thing. First, this while deck means this is checking is deck empty or not. If not, then go to the second statement of end array of deck of minus one. It means deck of minus one means the last value of deck array which denotes an index, and this index when we passed in array we have one value. Okay, and this value should smaller than the current value of array. Understand? If this condition will get true, would we would remove deck dot we used to call deck dot pop. This remove the last element and so on. As last element is smaller, we want to store elements in decreasing order. Then therefore we are removing the last element. Then we add the current element index to the deck dot append I, and this last condition, we use this last condition to append the maximum element of the current window to the result list. So this is very easy. I mean, we are just want to append the value in result. We can do it without if statement or not. No, we can do not. We should use. We have to use if statement here because um, um, I is greater than equals to k minus 1 means I should be greater than 2. If we see for k is equals to 3. Okay, so I should be greater than 2. This statement ensures that I mm, uh, I should iterate at least 3 element before appending it to the result. Understand? Because we want to find the maximum of k consecutive now. Therefore, this statement ensures that for before appending to the result, the I should iterate k times. Okay. And finally, we return the result. And this code is to take input. T is equals to int input means this is taking input for, and we use for loop for t times. Then we are taking n and k as input and this array as an input. Then we are storing this answer in the result and just we are doing formatting here. Okay, now run this code. Okay, we passed all the sample test cases. Now submit the code. Done. Thank you for watching this video.